everyone. I'm Nurul Hazrina binti Nordin from UMPSA STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to Chapter 1, Introduction to Raspberry Pi, our micro-credential course on Raspberry Pi installation and configuration. This course is designed to provide you with the fundamental knowledge required to set up and configure a Raspberry Pi. By the end of this course, you will be able to install and configure a Raspberry Pi for various applications. In Chapter number 1, Introduction to Raspberry Pi, students will explore diverse range of Raspberry Pi models, their differences and their common applications in real-world project. By the end of this lesson, you will be able to identify various Raspberry Pi models, including Raspberry Pi 4 and Raspberry Pi Zero. We'll understand the key differences between different Raspberry Pi variants, such as power processing, connectivity, and expandability. Lastly but not least, you will recognize the common use cases for each model, from IoT applications, AI projects to robotics and edge computing. The Raspberry Pi is a credit-sized computer designed for IoT automation, robotics, and learning. It runs on Raspberry Pi operating system, a lightweight Linux-based operating system. One of its key features is GPIO, also known as General Purpose Input-Output Pins, which allow it to interact with hardware components like LED, sensors, and motor. Python is the primary programming language used on the Raspberry Pi, making it an excellent tool for learning programming and developing real-world applications. The Raspberry Pi 4 is a compact yet powerful single-board computer. Let's break down its key component and understand how they work together. First is the processor, the CPU. At the heart of the Raspberry Pi 4 is the Broadcom BCM2711, a quad-core Cortex A72 processor running at 1.4 GHz. This processor handles all computational tasks, from running operating system to executing complex programs. It also includes an integrated Video Core 4 GPU, which supports dual 4K display and hardware-accelerated video decoding. Next, let's have a look into its RAM, the memory. Raspberry Pi 4 comes with multiple RAM options, 2GB, 4GB, or 8GB of LPDDR4 memory. More RAM allows for smoother multitasking and better performance in applications such as web browsing, programming, and even AI processing. This is where you insert your microSD card into the microSD slot. Unlike traditional computers with built-in storage, the Raspberry Pi 4 uses microSD card as its primary storage medium. The operating system, applications, and files are stored here. These are the USB ports and connectivity. The Raspberry Pi 4 has two USB 3.0 ports and two USB 2.0 ports, allowing high-speed data transfer for external devices such as flash drives, external drives, and peripherals like keyboards and mice. It also introduced Gigabit Ethernet port, providing high-speed wired network connectivity. This is the wireless communication unit. Wi-Fi 802.11 AC is built into the board, allowing for wireless internet access. Bluetooth 5.0 enables connection with wireless peripherals such as speakers, game controllers, and data sensors. The Raspberry Pi 4 is also equipped with display interfaces. The Raspberry Pi 4 supports dual 4K monitors via its two micro HDMI ports, a significant improvement over its previous model. These ports allow you to connect monitors or TVs for an enhanced desktop experience. This is the power supply and power management unit. Now, note that this Raspberry Pi 4 requires a 5V 3 ampere USB Type-C power supply to function efficiently. It includes improved power management, allowing for better stability under heavy workload. Now, this is where the 40 pins GPIO header is. One of the most important features is this GPIO. These 40 GPIO pins allow you to interface with external sensors such as LEDs, motors, and also other hardware, making this Raspberry Pi a powerful tool for physical computing and IoT applications. Now, these camera and display ports enables connection with Raspberry Pi camera module for projects involving computer vision and photography. The DSI display series interface ports allows the use of a Raspberry Pi touchscreen display, where this is the stereo audio jack. The Raspberry Pi Pico is a compact and energy-efficient microcontroller board designed for embedded systems, automation, and IoT applications. The Pico is built around a microcontroller and is optimized for low-power applications. Let's break down its key components. The main microcontroller is the processor RP2040, which is the Raspberry Pi microcontroller. It is a custom-built dual-core ARM Cortex-M0 processor running at 133 MHz. Unlike Raspberry Pi 4, which runs on an operating system, the Pico executes programs directly from its flash memory, making it ideal for real-time processing tasks like sensor interfacing and motor control. Here is the memory. The Pico has 264 KB of SRAM, which is sufficient enough for most embedded applications. Instead of using a micro SD card for storage, it comes with a 2 MB of onboard flash memory, where users' programs are stored. The Pico operates at 1.8 volt to 5.5 volt, making it highly flexible for battery-powered applications. It can be powered via USB or external power sources, such as batteries or regulated power supplies. The Raspberry Pi Pico features 40 GPIO pins, many of which support path width modulation or PWM, ADC (analog to digital conversion), and digital I/O. This includes a 3 12-bit ADC channels which allow it to interface with analog sensors, something standard Raspberry Pi model is lack. Unlike the Raspberry Pi 4, the Pico does not have built-in Wi-Fi, Bluetooth, or Ethernet. However, it can be connected to external modules such as ESP8266 or ESP32 for wireless communication. The Raspberry Pi Pico includes a USB 1.1 port which serves two functions. Programming interface. This is where the Pico can be programmed via USB by dragging and drop UF2 files or USB devices or host mode. It acts as USB device like keyboard or mouse or even a basic host in some applications. A unique feature of Pico is its programmable I/O (PIO) blocks, which allows customs, protocols, and high-speed data transfer without using the main processor. This is especially useful for handling LED matrices, signal processing, or even VGA output. The debugging pin, such as the one shown on the left-hand side, make Raspberry Pi easier for developers to debug code using external hardware, like a UART to USB adapter. It supports microprogramming in MicroPython and C or C++, making it accessible to both beginners and advanced users. The Raspberry Pi Pico is designed for low-power application, consuming only a few milliwatts when idle. This makes it ideal for battery-powered projects like the one used in remote areas and remote sensors and wearables. The 3.3 fixed output buck boost SMPS converter for regulating the power supply. This is an onboard buck converter, switching regulator, that efficiently steps down voltage from the USB input, typically 5V, to the 3.3V required by the RP2040 microcontroller and other components. The boot select button on Raspberry Pi Pico is used to put the microcontroller into USB mass storage method. The boot cell button on the Raspberry Pi Pico is used to put the microcontroller into USB mass storage mode, allowing users to flash firmware into the device. So this boot cell becomes very important when you want to flash MicroPython or CircuitPython or a custom UF2 file onto the Pico. Sometimes you would like to recover from a firmware error or resetting the Pico to load a new program and switching between different firmware, example from MicroPython to C or C++ or CircuitPython. Take note that the Raspberry Pi Pico features a built-in 12 MHz crystal oscillators, which provides a stable clock source for the RP2040 microcontroller, ensuring precise timing for processing, communication, and peripheral control. The Raspberry Pi Pico is a powerful yet energy-efficient microcontroller, optimized for embedded applications, automations, and real-time processing. While Raspberry Pi Pico lacks an operating system, Wi-Fi and HDMI output, its versatile GPIO, ADC, and PIO capabilities make it an excellent choice when it comes to projects involving electronic system, robotics, and IoT. Both the Raspberry Pi 4 and Raspberry Pi Pico feature GPIO pins, allowing them to interface with external components such as LEDs, sensors, and motors. Now, these GPIO pins are being clustered into a couple of groups. The first one is the power and ground pin. Both boards provide power output pins to supply external circuit. 3.3 pins used for powering sensors and modules that operate on 3.3V logic. 5V pins only on Raspberry Pi 4 used for higher power components like motors and display. The Pico lacks 5V GPIO as it is strictly available only for 3.3V device. Ground pins are used for common ground connections for circuits and peripherals. Secondly is the standard GPIO pins. Both boards have general purpose input-output GPIO pins, which can be configured into input mode to read digital signals such as from buttons or sensors, and output mode to send digital signals such as turning on LEDs or controlling relays. Raspberry Pi 4 has 26 GPIO pins, whereas Raspberry Pi Pico, even though it has 26 GPIO pins, it allows more flexible usage, including analog input, which is not available in Raspberry Pi 4. The third cluster is PWM pins, or stands for Pulse Width Modulation pins. PWM pins are used to generate variable signals, such as dimming LEDs or controlling motor speeds. Both boards support PWM, but the Pico has more flexibility, as any GPIO pins can be used for software-based PWM, while the Pi 4 has dedicated hardware PWM channels. The final cluster is the communication protocol pins. These pins are divided into three main groups, which are I2C, SPI, and UART. I2C stands for Inter-Integrated Circuit, which is used to communicate with sensors, displays, and other low-speed peripherals. Raspberry Pi 4 has two I2C buses, while Raspberry Pi Pico allows two I2C controllers. The second class is SPI, which stands for Serial Peripheral Interface, used for fast data transfer such as with SD cards and high-speed sensors. Both boards support two SPI buses, but Pico allows dynamic selection. And the final class is the UART, which stands for Universal Asynchronous Receiver Transmitter. These pins are used for serial communication between devices, like connecting the Pis to the GPS module or microcontrollers. Raspberry Pi 4 has one primary UART with an additional software configurable UART, while Raspberry Pi Pico has two UARTs with more flexible in-pin assignment. Raspberry Pi 4 has a more structured GPIOs layout with dedicated 5-volt pins, hardware PWM, and I2C or SPI or UART channels. Whereas Raspberry Pi Pico more flexible pins assignments, support analog input ADC, and introduces programmable I/O (PIO) for custom communication protocols. Now, let's compare the different variants of Raspberry Pi. The Raspberry Pi family includes models such as Raspberry Pi 4, Raspberry Pi 3B+, Raspberry Pi Zero, and Raspberry Pi Pico. Each of these models has unique features suited for different applications. Let's break down the key differences. The first one is the processor. The processor is the brain of the Raspberry Pi. Newer models such as Raspberry Pi 4 have a more powerful quad-core Cortex-A72 or A76 processor, making them faster and capable of handling more complex tasks. The Raspberry Pi Zero, on the other hand, uses a simpler single-core ARM11 processor, making it suitable for lightweight application. Secondly is RAM or Random Access Memory. Now, these RAMs determines how well the Raspberry Pi can handle multitasking. The Raspberry Pi 4 offers up until 8GB of RAM, making it ideal for running multiple programs or even desktop applications. The Raspberry Pi 3B Plus has 1GB of RAM, while the Raspberry Pi Zero has only 512MB, limiting its performance to basic tasks. The Raspberry Pi 4, which is designed as a microcontroller, has just 264KB of RAM, as it is optimized for embedded system rather than full operating system. Next, let's look into the connectivity. Different Raspberry Pi models offer various connectivity options. The Raspberry Pi 4 and 3B Plus support Wi-Fi, Bluetooth, and Ethernet, allowing for easy network access. The Raspberry Pi Zero has no built Ethernet, though it does support Wi-Fi. The Raspberry Pi Pico, being a microcontroller, has no built-in network capabilities and is instead designed for hardware-level control. Next, let's have a look into USB ports. The number of USB ports determines how many peripherals you can connect. The Raspberry Pi 4 includes 4 USB ports, including 2 USB 3.0 ports for high-speed data transfer. The Raspberry Pi 3B has 4 USB 2.0 ports, while the Raspberry Pi Zero has only 1 micro USB port, requiring an adapter for regular USB devices. The Raspberry Pi Pico does not have USB ports for peripherals but includes a micro USB power and programming. Finally, let's have a look into its GPIO capabilities. This GPIO allows Raspberry Pi boards to interface with sensors, motors, and other hardware devices. The Raspberry Pi 4, 3B Plus, and Zero all have 40 GPIO pins, making them versatile for electronics projects. The Raspberry Pi Pico also has 26 GPIO pins, but is designed specifically for microcontroller-based projects, offering additional flexibility for embedded system. Now, let's have a look into each special features. Each model has unique strength. The Raspberry Pi 4 supports dual 4K display, making it a powerful mini computer. The Raspberry Pi 3B Plus is a great all-rounder for IoT and robotics projects. The Raspberry Pi Zero is ultra-compact and power-efficient, perfect for portable applications. The Raspberry Pi Pico is a microcontroller designed for embedded system and hardware control. The options of these Raspberry Pis depends on project requirement. Now, the most recent Raspberry Pi 5, for example, is the latest and most powerful model. It featured 2.4 GHz Cortex-A76 processor, 8GB of RAM and PCI expansion support. Well, this Raspberry Pi 5 offers a significant performance boost compared to previous model, making it ideal for AI, edge computing and high-performance applications. In comparison, the Raspberry Pi 4, the Raspberry Pi 3B, such as the one shown here, offers a balance between affordability and capability. The Raspberry Pi Zero is a compact low-power option for IoT, and the Raspberry Pi Pico is a microcontroller designed for embedded systems. With these options in mind, selecting the Raspberry Pi depends on your project needs, whether it's a full computing experience, IoT development, or real-time embedded system.